That's good. Hi everyone. Welcome to another session of data structures. So we are discussing this linked list algorithm. Our algorithm, the algorithm that we are discussing is this one. Basically, I think tenth one. Yeah. Um, Reverse a linked list in a group of a given k. That means if I say three, we need to reverse three every three elements, something like that. So how to do this? So before going to that detailed algorithm, I want to explain the basics of linked list, how the linked list will work. Welcome to new folks. I think Venki joined and some other people. Welcome to the class. So I'm discussing linked list. Anytime unmute and ask any questions. So as I said before, I use C sharp as my language to showcase the algorithms, but pretty much it is exactly the same in every language. So in a linked list, this is how the data structure is defined. A linked list has two things, right? The data and the next address. So if we try to write, oh, just I forgot the pen. Actually, I will bring a pen. I use this inking alphabet app. This is the app I built a couple of years ago. So linked list is something like this, right? Every linked list has two things. First one is the data, and second one is the this is the data, and this is the next address of the next element. The next one
Hello,
data.
sir. Your screen is not visible, sir.
Oh, my screen is not visible. How about you, Taran?
Sir,
Can
it's
you
visible.
can't see my screen?
It's visible, sir.
Oh, that's great. Yeah, Jay can see it. Maybe you try to join again, like disconnect and join, then you will be able to.
Yes, sir. It is visible, sir. Present.
Yeah, just a minute. Okay, so I'm just unmuted. So that is what the main data structure. The data structure of the linked list node is like this. We have a data and the next address of the next node, right? And here is the constructor, and add links is I just created a method called add links. That is where I can just provide the next node, and I'm connecting present node to the next node. Okay, so this is how I create the linked list. Basically, if we create a linked list, so I will create nodes individually, n1, n2, n3, and I'm going to connect the nodes n1 to n2, n2 to n3. So somehow we have to create linked list, right? This is the way. So and printing a linked list, we can think head and one is the head. So if you have three nodes, one two three, so first one is the head. And how to print the linked list? So printing a linked list is just writing a loop here. So what I'm doing is while loop is best one until n not equal to null, n dot data, and then I'm printing like a arrow, and then n equal to n dot next. So what will happen is it will print all the elements of the linked list. Okay, so I'm going to run this algorithm and show the outputs. So this is the basic algorithm. We haven't started the main algorithm. I'm going to discuss couple of problems here. So what I did here is initial linked list. Now adding, right? So here is the we want to add an element. Adding an element to the linked list. How can we add an element to the linked list? There are multiple ways to add. Usually we will add at the end of the linked list, right? So let's look at the algorithm of that. So this is an adding element at the end of the linked list. So let's assume, right, this is the how to add the new node. This is the data. We are providing a just data add 4, right? So if you call this method without even creating any nodes, that means let's say head is here on top of the algorithm. We created a pointer called head. Where is it? Yeah, here is the head, right? Head is null right now. That means what is happening here is if you did not even create these nodes n1, n2, n3, That means there are no elements, right? Then if you directly call this add new node 4, so what are you saying is you are asking to create a brand new linker list because there is no nodes, right? That is the first condition. When you are adding an element, what we do is simply I just created a new node with this provided data, whatever the 4 or 5, I'm just creating a new node. Now this is the initial condition. Is head empty or not? If head is null, that means there are no nodes present in the linker list. You simply assign head equal to new node and return. You are done because there are no nodes until now, right? But in this situation, in the situation above, before we calling this, what we did, we already added 3 nodes. So this condition will be false, right? So what is happening here is we need to take a pointer. This is a temporary variable to navigate the elements of the linker list all the way from the first element to the last element. That is the main um, um, theory here. So in the normal arrays, we can simply use for loop. Very easy to navigate the elements in the link in array using for loop. But for loop will not work for linker list. Of course, we can make it work, but it is always better to use while loop in order to navigate the elements of a linker list. Okay. So here is a pointer. I just assign the pointer to the head because if head not equal to null means it comes to the line number 91. That means there are some elements. It could be one element, it could be two elements, or it could be 1,000 elements. We don't know, right? Our intention is to go all the way to the end of the linked list and add this new element. This is the new node. We need to add this element at the end of the linked list. So simply what I'm doing here is a while loop while pointer dot next not equal to null. That means if pointer is a particular node, pointer dot next not equal to null. So we are looping until we find the last element. See, the pointer should be at the last element. We never say like pointer not equal to null. So look at the difference between this condition and this condition. The printing, while printing, you print all the way to the last node and then for the last node, what will happen? N equal to n dot next. That means n becomes null. Finally, you are stopping if n becomes null. But here we are stopping when the next node is null. Because if the next node is null, pointer dot next is null, that means pointer is pointed at the last node. So this is very important in the linked list understanding and writing a proper condition. The stopping condition of the loops always different. Every algorithm, every method has this while loops and all the conditions are always different. So please try to understand why we wrote like rather than writing something like pointer not equal to null. If you put pointer not equal to null, what will happen is you are just navigating all the way to the null at the end of the linked list, and you can't even add a link to that new node, right? So in order to do that, we need to do this pointer dot next not equal to null. We are looping until we find the last element. If you find the last element, we are in a good shape. So we just link to the new element. So look at the comment I wrote. That means until pointer pointed to the last element, right? So pointer pointed to the last element means whenever that happens only when pointer dot next equal to null. Because for the last element, if you look at the next address is null, right? That's why we put this condition. If the pointer dot next not equal to null, that means there is an element next to it. So please go to that element. Pointer equal to pointer dot next. So it will go all the way to the last element. For the last element, pointer dot next is null. Then it will break. Now we are updating. We are overwriting pointer dot next equal to new node. You guys you guys understood the algorithm here. So we created an orphan node. This is orphan node. This is not even connected to any node. So later we connected with the last node. Okay, I hope it is followed
Yes.
so far. Yeah. So let me bring my I have uh, a pen there where I can easily write and explain these algorithms for the people who may not be able to follow. Just give me a minute, I will get the pen. Okay. In the meantime, discuss the algorithm. Let me. I will show the. I will show the code in the meantime. Yeah. So, okay, I'm back here. Okay, now I'm going to write and show you. Okay. So as I said, what we did, we already have a linker list, right? We have a linker list of some elements. It could be two elements or it could be three elements. So what we did here is we added a new element called number four, and it's not linked to any node yet, right? So now we took a pointer. Pointer started with head. If pointer dot next not equal to null, pointer goes to the next node. If pointer dot next not equal to null, pointer to the next node. Pointer equal to pointer dot next, right? Now what happens here? This is a null. This pointer dot next, this is the next pointer is null. That's where this condition will break. Now what are we doing? Now pointer is pointed to the last node, right? After the while loop, pointer is pointed to the last node. Now what are we doing? So we have 1, 2, and 3 here. So now pointer dot next equal to new node. That's what we are doing here, right? So the line number is 97. Pointer dot next equal to new node. New node is the node we just created in the line number 86. So simply we connected with that new node. That means now the head is here. Head is always for first point, first one. So head connected to one, one connected to two, two connected to three, three connected to four. We no need to worry about pointer. We just leave it. So by the time you complete this algorithm, so we no need to worry about pointer. So pointer is just used for our easy navigation. Okay, just like I in the for loop, we always have I equal to something, right? In the normal arrays, we always have that variable. Similar to that, here we used pointer variable. Okay, so I hope it is understand everyone. Everyone, anyone have any questions on this one? I just want to give updates to the basics of the linked list. I don't want to explain the complex algorithm because it looks like so many new people joined. So I want to make sure everybody understood the basics of the linked list. Please give a thumbs up if you understood. Like otherwise, it will confuse for me. I don't know whether you're following or not. Or put a message in the
Yeah, sir, it's
chat.
pretty much clear.
Thank you. Yeah, you can also say in the anyone can also say in the chat if you. Yeah, that's fine. Great. Check this MD file. It will be helpful to understand basics of the linked list. Or somebody, very good. Some Sunil Kumar, very good. You sent some uh, README file or something like that to GitHub. Very good. What is linked list? Very nice. Somebody prepared. Sunil, is that the blog you prepared?
Yes, sir.
Very nice, man. This is really helpful. Yeah. Wow. Beautiful, beautiful diagrams and yeah, new node. See this? This is the interesting part. You added new node at the head of the linked list, isn't it? Right? So if you want to add at the head of the linked list, it's easy. It's not that difficult because you have head and you can just add at the beginning and you change the head, right? But how to add at the end? This is what you did here, right? How to add element at the tile node. So very good algorithm. This is exactly what I just explained. Okay, so looping and then adding to the end. how to add element at the given position. This is also important. We discussed in one of the algorithms. So we want to add in the middle, right? This is very good. And how to delete the head node in the linker list. Very good. So please go through this. It will be very helpful. Very nice, nicely prepared, Sunil. Very good. So why don't you start explaining an algorithm? So because just creating a blog is one part, and expressing your ideas is also very important, because that's how you're able to succeed in interviews, right? So why don't you take up a class next week or so on a particular algorithm? Praveen said, learn this complete concepts in C sharp. Yeah, these concepts are pretty much same. It doesn't matter whether C or Java or C sharp. These are basics of computer language. Pretty much the same. Uh, Sunil, yeah, if you're still there, yeah, Sunil, why don't you start a session? Like you can also take up a algorithm and explain. Are you up for that?
Yes, sir, sure, sir. Next week I will try it, sir.
Very good, very good. Yeah, the pick a program in any of the algorithm, not only list, any your favorite algorithm, and explain, because that's how you able to communicate your ideas, and it will definitely helpful for interviews. I encourage everyone, Tarun, Sunil, anyone in this session, if they want to start, because the way we need to explain, it really helps in the interviews, right? Interviews is just like you can treat the interviewer as another student. How are you going to explain your concepts to that student? Don't think that he is a boss or he knows everything, or don't think that way. You can think of as a student, or you can think of as your friend, as your colleague. So how do you explain? So let's say you both working on a same project. You are working on one module and your friend is working on another module. So how are you going to explain your module or your project to him? That's the way, right? So if you practice in these sessions, offline and before going to the interview, this will be helpful when you go to the interview. So Tarun recently attended an interview. Tarun, do you want to share any experience of your recent interview? What questions you got and how you explained? Yeah.
Yes, yes, Suresh. Like basically, they went to from medium level to advanced level. They started with recursion, and they asked me to write few. They asked me to write merge sort and insertion sort,
Mm-hmm.
and they went for searching algorithm,
Mm-hmm. Bind
and
researching.
they
Bind researching.
yes,
Very good.
yes, yes,
Okay.
yeah, and they went as it is a like full stack role, so they went on code side of front end,
Okay.
and yeah and they asked on SQL queries, and they asked me on TypeScript, and
My God.
they tested me on HTML and CSS.
My gosh. So many questions. How many rounds? Is that all in single round?
Yeah, yes, Suresh. Like they touched every tech front end and back end, like with 2 3 questions.
Mm-hmm.
It went like 1.5 hour like that.
My gosh. 1.5 hour. Very good. Yeah. See, this 1.5 hour means like they are keep on asking you, keep on telling me. That means they want to see how deep you are. They are already impressed. Otherwise, they don't even continue that far, right? So very good. So you prepared all the sorting algorithms and searching, binary searching before.
Yes, Suresh.
Very good. Very
I
good.
prepared.
Very good. Yeah, we haven't discussed those yet. So binary searching is very important. I don't know whether we discussed in our strings or arrays, but very important algorithms. Those are very important. So we will get in the trees also. We'll get binary search algorithms when we explain the trees, and when we explain graphs. There are a couple of important algorithms we will get, but you have to prepare well. So that's very good, Tarun. So good job, and it will be helpful. So when you start explaining your algorithms, when you start explaining your thought process, they always help. Okay, so now coming back to the algorithm here, what else we discussed so far? Here we discussed about adding a node, right? So coming to the, if you want me to continue here, we can also discuss the next one, deleting a node. So how to delete a node, right? So deleting is also same thing. I just provided a data. So if the header data equal to data, that means if the data that you want to delete, let's assume that every node has a unique data. Okay, 1, 2, 3, there is no duplicates. So if I say 1, so you are asking me to delete head node, right? So this is a special case. If you want me to delete the head node, if the head dot data equals the data that you want to delete, we simply navigate head equal to head dot next, removing the head. This is called removing the head. Basically, we need to change the address of the head. We have to overwrite the head. Unless this is the only case, insertion at the head and removing at the head. These are the only two cases we change the head. We don't want to change head quite often. Okay. So Praveen is saying learn this concept, sir. He was talking in meet, sir. Came the address versus previous node, delete node. So speak up, Praveen. If you have any questions, no problem. Um, yeah. So basically, this
Sir,
is yeah.
sir, don't we have to free the memory?
Very good. Very good question. Very good question. So, yeah, we are talking about if we are talking in the real sense of C language or C++ in a deep understanding in the sense, definitely we have to free up the memory. But here we are talking on abstract language like a C sharp or Java, so which has a garbage collector. That means if a particular
Okay, sir.
element in the memory, if the particular element or object in the memory that is not referenced by any other variable in your program, that will be automatically claimed by the garbage collector. So my intention as an interviewer is to write the logic. How do you write the while loops, and how do you make sure you have the right algorithm or logic? So I don't care how do you free up the memory, because as an interviewer right now we are in a state where we no need to know the deep internals of any algorithm or any technology right now, right? So people coming from all the different streams to computer language, now computer languages are so sophisticated. So C sharp, Java, every other language has garbage collector. So I don't need to pinpoint you on how do you free up the memory, right? There will be some tools available, or automatically taken care by the garbage collector. So that's why this is a very good algorithm. So this is a very good question. Somebody will ask you, hey, what happens to the memory? So you can say that. So even if I don't ask in the interview, you can just put that word out while you're explaining this. Hey, I'm just moving to the next element here. So the reference before the old element will be taken care by the garbage collector. Okay. So very good question. So yeah, please speak up anytime, unmute. No need to wait your question, or you can either put it in the chat or please otherwise unmute. I'm seeing Chandana is there. Welcome, Chandana. Is it first time? And Sam is already we introduced. Yeah, anyone speak up and talk. Chandana, where are you from? Are you also doing BTech, or give me your intro if possible? Can you hear me? Anyway, yeah, let's go ahead. Yeah, please go ahead, Chandana. Where are you from? Are you doing BTech, or are you doing job? Yeah, please introduce yourself and connect with the Discord channel. As I said, this is where I will post all the questions and recordings and everything. So I just shared all the details in the in the in the Google Meet, this GST chat. So I'm in my okay BTech. Very good. Okay, third year, second semester. Very good, very good. So yeah, this is a very correct time. All the people who are in the BTech and final years, they can prepare well. If you focus on these elements, these very important algorithms, and you will be able to crack the interview very easily. So consistently prepare 1 or 2 algorithms a week. You don't need to prepare tens and hundreds. Just Just focus on one or two algorithms a week is more than enough, because I know you everyone have a lot of you know courses to finish and lot of class work to complete. But at the same time, if you want to settle an IT job or developer job, this is also very important to learn at least one or two algorithms a week. So we discussed the deleting node. So here we are discussing about it. So let's say if you want to delete the head node, this is how to do this. Head equal head dot next. Unwritten. We are done, right? Now this is not the case. If it is fails, if it fails, that means we want to delete something which is not the head, right? So we do the same thing. We take the pointer and pointer dot next not equal to null, the same condition which we had before. Now the only thing changes here is here we are going to the last element in the adding state, but here we want to see whether the next element data is the data that you want to delete. So here is the very important condition. So pointer dot next dot data equal to data. We are comparing the data of the next element, not the current element. Why? Anyone can tell why we are doing like this? Why don't we do like pointer dot data equal to data? Actually, the answer is on the next line. Actually, 109 is the answer. Anyone tell why we are comparing the next element data?
Sir, so that we don't lose the reference of the current node that we
Exactly.
have to delete.
Exactly. That's correct. So let's say this is the example. If I go back to the whiteboard, right? So we have these elements: one, two, three, four. One, two, three, four. So now what I'm saying is I want to delete number three, like node with value three, right? So it's not head node, so head start with this and pointer also starts with this. So what I'm saying is I want to delete the three. What here essentially here is, if you want to delete three, what node we need to update? Deleting three is it's if it is arrays, it's completely lot of work. So the main advantage the linked list will give you is easy deletion, easy insertion. If you want to delete the middle element in the array, right, you cannot delete unless, like, if you want to delete, you need to shuffle all the elements, right? This is the only way. You need to shuffle the value from here to here, here to here, here to here. That is the only way you can delete this element. Otherwise this element is always be there. But here in the linker list, it's easy. You can just remove the links. It's just like our chain, right? Let's say one of the ring, like you have a big chain, um, and one of the middle part is not good or something happened, you just remove that part and connect the rest of the chain. This is just a chain, right? So, or necklace, something like that. So you want to delete three. So if you want to delete three, right? So which element or which node we need to change? Can anyone answer?
So we need to change the uh, link of the second node, the next
Very good.
pointer of the second node
Very good.
to
Very
the fourth.
exactly.
Yeah.
Very good. That's a good answer. So basically, two is saying two has the address. Basically, if you are looking at the inner memory, right? So these are all in a different places. So one is somewhere, two is somewhere, different places. So basically, in every node there is an address part. The next part is saying, let's say this one is 1111. This one is 1112. This one is 1567. Right? Just I'm giving some random addresses. 18 this is the address of this node in the memory, right? So it is saying 11. So here is one, this is the address of this node. So that means the next address here, this is the value here is 1112. That means the after connecting to one, go to this address. What is here? 1112 is node 2, right? After here, what is the value in the next value? It says 1567. Go to this address in the memory. What is in the 1567? Node 3, right? So what is here in the next value here is 111818. Go to 1818. This is the address of the next node. The 1818 is number 4, right? So here what are we essentially doing is we want to get rid of number 3. That means if you want to remove the node with 3, basically we have to update the node with before the node, the previous node. That means we need to erase this value here. We need to erase this value. And what value we need to put there? Can anyone guess what address we have to put there?
1818.
Exactly, we need to put 1818. But how do you know 1818? You are looking here, right? You're looking here. What is
Sir,
that?
it is stored.
The
It
next
is
address.
stored at 1567.
Exactly. So whatever this 3 is connecting, it could be 1818, or it could be 1111. We don't know, or it could be 1616. We don't know. This address you are looking at the whiteboard. Since you are looking at the whiteboard, you can simply say, "Hey, put 1818 here." Then 2 is connected directly to this node, right? But if you are not looking at whiteboard, has an algorithm, the algorithm need to analyze and get the value. So how to get the value? Just you need to update the previous node. That means the pointer need to stop at this node. Pointer need to stop, because you need to update pointer dot next value, right? And how to assign, what value you need to assign? You simply assign the next value of the node that you want to delete, isn't it? No, this is the node that you want to delete. You want to delete the node with 3. So you just get the next value of that node that you want to delete, and put that next value into here. What is the next value here? 1818. Put that 1818 here. Pointer dot next. That's it. Your job is done. So this link is created. And now none of the, because this link is broken, right? Now the 2 is not connected to 3 anymore. 2 is connected to 4. Now none of the nodes or none of the variables in your algorithm pointed to 3. That means 3 became an orphan node. Whenever 3 became an orphan node, of course 3 is still connected to 4. Remember that. We did not remove this link. 3 is connected to 4, but that doesn't matter. The garbage collector always looks at the reference to that memory. Is there any variable in the algorithm that is pointed to this memory 1567? No, there is no other variable in the algorithm that is pointed to 1567. So then it will reclaim that memory. That is how the garbage collector works. So what happens here is, that is what we are doing here. So we need to stop at this location. Pointer dot next dot data equal to data. So pointer dot next dot data. So this is a pointer. Point, let's say start from the head. Pointer dot next dot data. What is the next dot data? 2. Is 2 equal to 3 that you want to delete? No. So pointer goes to the next element. That's what we are doing. If it is not, you just go to the pointer equal to pointer dot next. Again, it goes back to the 107 and not equal to null, and pointer dot next dot data equal to data. Now pointer is 2, pointer dot next dot data is 3, 3 equal to 3. Yes, that is where we stop. So pointer dot next dot data equal to data that you want to delete. So we are simply overwriting the value. Pointer dot next equal to pointer dot next dot next. You got the point? So here pointer dot next is
Sir, I
3.
have a question.
Please go ahead.
So, sir, uh, in this delete node function, we
Yeah.
are passing the data.
Yes.
So, every node which has that data, that will be deleted
Yes.
from the linked list.
Not every, no, 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 no,
For
no, no,
example,
no, 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 no. This will delete the node with that data. Let's assume
which,
that let's assume
which,
that
yeah,
linked list has a unique elements. Just that's a condition that I am saying. Linked list has unique elements.
okay,
There
okay,
is
sir, okay, okay.
only one node called 3. Okay, and we are just deleting the 3.
Okay, sir. I was assuming that there may be multiple duplicate
No,
datas.
no, that could be completely different algorithm. You are That is also valid algorithm. Like let's say I'm giving a linked list of all the students. Okay, and every student we are saying the color of the t-shirt, the red, green, yellow. I'm asking you, remove all the boys or all the students who have red color t-shirt. That is the algorithm. So wherever you find red, remove that guy. Red, remove that guy.
Yeah,
So
yes, sir.
that is
This
a
algorithm
completely
will work
different
in that
algorithm.
case.
What's that? Yeah.
Sir, I think this algorithm will work on this case also.
No, I don't think this algorithm will work on this case, because look at this. I am returning, once you find the value, I am returning the algorithm. I am just breaking the loop and I'm
Oh,
completely returning,
okay, sir. Okay.
because the initial
So it
attribute.
will remove the first occurrence.
Exactly. It will remove the first occurrence of that particular say, particular value.
Okay, sir.
So because
Okay,
I
sir.
don't
If
want to
we will
complicate
not
the,
return here, then
what's that?
if we'll not return here, then
Yeah,
it might work.
if you don't return here, what happens here is you will go to the again while loop and it will check for the same. It may work the way you are expecting. Let's say, but I don't want to complicate the basics. This is just a basics algorithm. So to understand the linked list, how it works and everything. So this is absolutely what we discussed here. Is also another valid question. I am asking you to delete all the values with all the nodes with value 3. If I'm saying like this, that is all. These are that in that case you can think of as a linked list with multiple duplicates, and you are removing all the values with 3, right? That is completely different algorithm. So in that algorithm, you should not return. You should not return. You will continue the algorithm, right? So here I'm just returning. Once you found a node with the data, I'm updating the next pointer dot next. This is pointer dot next is pointer is 2, pointer dot next is node 3, right? Now I'm updating pointer dot next, that means 2 dot next equal to 2 dot next, that means 3 dot next. So whatever the 3 dot next value, that address is copied to the 2 dot next value, and I'm returning. So that is the algorithm to return the particular. So note, if it did not return, let's say it comes to the line number 115, what does it mean? That means it broke this condition, pointer dot next equal to null. Pointer dot next equal to null means it reached all the way to the last node, right? So it reached all the way to the last node. So now your, if I pass something like a 10 or something, then you did, there is no 10 in the linked list. That means that's what, no node found with the value data, because you compared every data of every element, and you reached all the way to the last element. And of course last element is also compared here before it reaches the last element, right? So last element is also compared, so none of the elements matched with the value you provided. So no node found with the value. Okay, so that's how the deleting the node. So I'm covering the basics today, rather than covering the deep algorithm. I hope it is helpful. So let me know, Chandana or Sam or anyone. Jay, is it helpful to go through the basics today? Right?
Yes, sir. Yes, sir.
Very good. So here is another algorithm called reversing the linked list. So here is also very important aspect, very in the point of in terms of interview as well. So look at the outputs here. I keep on I printed couple of sample test cases. So initial list is 1, 2, 3, 4, and the list after adding second element. So I added second element, like here is the first so adding first element, so we added element here, so we added 5 here. List after deleting an element, so we deleted an element 3. See that, element 3 deleted. Now 1, 2, 4, 5. And list after deleting the head, if you delete the head, what happens? 2, 4, 5. And node found with the value, so no node, so I'm saying like delete 10. So here I'm calling, yeah, look at this, delete 10. There is no node with 10, right? So that's the next one. List after deleting not found element, so it's still list is same thing, 2, 4, 5. List after reversed. Okay, this is the next algorithm, how to reverse a linked list. reverse the whole linked list. It's not printing reverse. There are two ways actually. Without even changing the linked list, you can print the linked list in a reverse order. But here I am asking you to reverse the whole linked list. Okay. So any idea how to do this? This is also very tricky algorithm. So if I say like this, 1, 2, 3, 4, right? So head is pointed to here. What I want here is ultimately I want like this. Head pointed to here and 4, 3, 2, 1. Okay, we want something like this. So now head is pointed to 4. The first element is 4, 3, 2, 1 is the last element. So how to do this? Have you anyone tried before?
Sir, we can store the elements in an array
Very good, very good. So you store the elements
and
in
then
an
reverse it.
so you store the elements in an
Yeah, and
array.
then create a new linked list by the reversed array and put the head pointer to the head of our linked list.
Very good. So you can do that. But what is the complexity of that algorithm? The
Sir,
space,
O of
time
n is the
complexity.
time complexity and O of n space complexity.
Very good. So that is the main problem, right? So time complexity is of n. You cannot remove, you cannot reduce the time complexity here because you have to navigate all the elements at least once. So that is for sure. You cannot solve this problem without navigating all the elements. So order of n is fine, but space complexity, you are taking another big array of the exact same input. If I give you million elements, you are taking another array of million elements. Is it really necessary? Can we optimize this one? So without using another space, can we do this? That is the question here. Because linked list is always just a manipulation of addresses, right? So basically one connected to two,
Sir,
if you make two connected to one, then you're in a good shape. But of course, this is not a double linked list. That is the main challenge here, right? Go ahead, Sunil. Sunil or whoever it is. Yeah, Jay.
yeah, sir, I think we can create a new linked list
Mhm.
and we can always traverse to the last element of the first linked list and remove it.
You can create new linked list.
Okay, sir. Sir,
Can
when
you
we
can
are
you repeat?
creating a new linked list,
Okay.
yeah, we will check the last element of the given linked list
Mm-hmm.
and add it to our created linked list. Like we will add 4 to our new created linked list
Okay. You create the four. So, but
and
yeah.
delete the 4 from the given linked list.
How do you delete? Again, you need to navigate to the third, right?
Yeah.
Okay. So you created four, and four need to connect to three, right?
Yeah. Now 4 is deleted and we are at 3. Now 3 will be added in our linked list.
Hmm. So three will be added at at the head of this linker list. No, not head. Probably
No,
you
sir,
need
at the tail, at the
at the
tail of the
side.
linked
Yeah,
list,
at the
at the
side.
tail of the
So
linked list.
you will add three here and four connected to three. But again, that's a good idea. But again, now you need to delete three. So again, you need to navigate from head to the two. In order to delete three, we just discussed about it, right?
Yes, sir. Second
The-
last element to the.
Again, you need to start from the beginning and find the two, and then you can delete three. Now you need to delete two. Again, you need to start from the beginning. Here it is like it's a good algorithm, but the problem here is you need to start from the head
Sir,
every
O of
time.
n square. It may be take O of n square.
Yeah, it is on square, but
But
it is
space is
yeah.
1. Space is 1.
Space is not one. You are creating new linked list. You're not. You're not.
Sir, but we are deleting that particular element.
I see. I see. Okay. Okay. Space could be
When we are
order of,
adding
but
the
your
element to our linked list, we are
yeah,
removing.
your algorithm is good. You're making the space. You're not creating another array, but another set of elements. But the time complexity was worse. You need to navigate from the beginning every time in order to find the before element. because you cannot navigate backwards.
Uh,
You always need to start from the beginning and find out the element, right?
yes, sir.
That is order of n square, which is not good. So how can we do in the order of n, order of n, and
And
order of
space of
one
one.
space, order of n time complexity, and order of 1 in the space complexity? This is the main algorithm. Basically, here we are not taking any extra array or a hash table or anything, okay? But at the same time, we are not increasing the time complexity. We are just navigating only one time, okay?
Okay, sir. Sir, yes, we have one as an head node in the given linked list.
Yeah, yeah, head pointed
So
to 1.
one should, but in a result linked list, one should point to a null value.
Null, exactly.
Yeah. So, sir, the link of one should be null and the link of two should be one.
Yeah, how can we do that? So,
Sir, if we create a link to the null,
mhm,
then the link from the second, the reference of the second will be lost.
yeah, that's
Sir,
right.
maybe we have
If
to
you
take
connect
some
these two,
dummy nodes. We have to
exactly.
take
If you
some dummy
connect 2
nodes.
to 1, you lost the reference to the 3. That is what the exactly what you're coming to the exact
Sir, if
algorithm.
we take a dummy node, we can store that temporary
Exactly. We
node.
will take another pointer that points to this node. Yes, yes, you're right. So simply by taking few variables, you can manipulate this reference problem. You can manipulate these links. Okay. So you are at the correct, you arrived at the correct solution. Basically, you need to take a couple of pointers. Just I took 3 pointers irrespective of the node. So that's why I'm saying, like, where taking variables is not a problem. It doesn't increase the space complexity, as long as as long as the number of variables are constant. So here, the node here could be million elements, 1,000 elements, 100 elements. I don't care. I'm always taking 3 pointers. It's a constant number of pointers. That's why it is constant space. So what I'm doing here is P1, P2. Okay. So here is the, I think this, let me show you. Reverse the entire linked list. This algorithm is better than, yeah. I think this is way better than, rather than saying P1, P1, P2. This is a way better. This is exact same algorithm, by the way. So here, what I'm doing here is there are 3 variables I'm taking: previous, current, next. Okay. So what is previous, what is current, what is next? Simply, if you take this, right? So if you take, let me remove this. So basically, there are 3 variables always needed. What is previous node that I want to connect, and what is the current node that I want to change, right? And also, what is the next node that I want to tackle, right? So I'm trying to delete each and every node here. Okay, so here we have 3 things we need. This is previous, this is current, and this is next. Okay, you guys can see my whiteboard, right? So
Yes, sir.
these are connected like this. So now what we need to do is, like, we need to change the current node's address to previous node, and and previous node previous node is connected to current node, right? Previous node will be there. Previous node, if it is first node, you connect this to null. If it is not, you connect it to the previous node. So let me tell you. So what I'm doing here is we took the 3 variables: previous, current, and next. First, current is pointed to head. For the head, what is the previous node? For the head, previous node is
Null, sir, null.
null,
Null.
right? And the next node, we don't know the next node. We will figure that out, because we know the current next node is next node. We just assign to null, but we will figure that out. So do this, do a while loop as long as current node not equal to null. Current node is a valid node. So head is a valid node. Now what are we doing here? Next node, we are saving the next node address. This is what you talked about. Before we update, so before we update the current node, before we update this is a current node, right? Before we update this value, because we need to connect this to here, right? Before we update, we will put that value, that address in the next node. Next is the value. That's why we are saying next. Save the next. Here is the next thing you want to tackle. So next equal to current dot next. Now you can happily update the current dot next, isn't it? It's just like swapping A B. It's a very basic algorithm you might practice it before. A equal to 10, B equal to 20. Swap A and B values. What do? You put the A value in a temporary variable T, isn't it? Then you can update the A, right? T equal to A equal to B equal to T. So very simple swapping algorithm that you all learned in your previous classes, I think in your academics, right? Similarly, we are doing just temporarily placing the next address in a variable. So the current dot next in a next variable. Now you can happily update the current dot next, isn't it? Now current dot next equal to whatever is the previous. There is some address in the previous, whatever is the previous. Right now previous is null, but previous could have something else later on. So whatever is the previous, connect the current node to the previous node, right? That's what it is. So the current connected to the previous. Right now previous is null. So now what happens here is, for the first node, what happens? For the first node 1, right? So 1 dot next, whatever the next, so next becomes 2, right? Now 1 dot next becomes null. This becomes null because previous is null, right? Previous is null, so there is no node. Now what happens here is, now you're done. Now what I'm saying is, consider the current node is previous node. That means previous equal to current. That means you completed processing this node. You completed processing this node, right? Now you consider this as the previous node. It's just sliding. Basically, it's a kind of sliding thing. So now consider this as the previous node. Previous equal to current. Now current equal to next node. Now this becomes current. You guys understood so far? It is really tricky. So let me give you in a different way to understand. Okay, 1 here, 2 here, 3 here, and we have 4 here. Okay, so now I will take a table here: previous, current, next. Okay, what is previous initially? Null. What is the current?
Null.
Current equal to 1.
Head.
Current, look at the initialization here. Current equal to head. Now next equal to null. Next is also null. This table will help you. Next is also null. Okay. Now what we are doing in the first line? Next equal to current dot next.
Current. Current. Okay.
Current dot next. Next equal to current dot next. That means next pointer to which node? This is current, right? Current dot next means 2, isn't it? Next equal to current dot next.
Yes, sir.
Now what are we doing now? Current dot next equal to previous. That means current dot next equal. That means now we are updating this. This is updated to null. We basically we are removing this chain. We removed this link. We made the one as orphan, right? We made
Yes, sir.
we made one as orphan element. That is fine, because look at the next one. Previous equal to current. Now previous is null. So far previous is null. Now previous becomes current. That means previous becomes 1. right? Now current equal to next. Now current becomes 2 because next
2.
is 2, right?
2.
Now what is current? Current is here, right? Now let's look at the while loop again. Current is not equal to null. Yes, current is not equal to null. Next equal to current dot next. What will happen here? Next equal to current dot next. That means what is the next value? Current dot next. Are you guys following?
3.
3. We need
Yes,
to
sir.
update. We need to update this address, right? We need to update this address. This need to connect to 1. But before updating this, we are storing whatever is that value. We are storing what is the current dot next, that is 3, in the next value. Basically, we are not storing 3 actually. We are storing the address of 3. This is address of 3, right? This is the address of 3. A of 3. Address of 3 will be stored here. Now, we are happily ready to change here. Current dot next equal to previous. What is current dot next? Current is true. Current dot next equal to previous. What is previous? Previous is
1.
1 here. So 2 dot next connected to the node 1. Now we are chaining. Now 1 is not orphan anymore. Until now 1 is orphan, but now 2 connected to 1, right? Now next value
Yes,
previous
sir.
equal to, now previous equal to current. We are done with 2. Now 2, now previous equal to 2. We are making this as previous. We are making this as previous and current equal to next. Now current is 3, right? Now current equal to 3. We are considering this as current. It's like 2 pointer. Basically, previous points to the previous element, current points to the current element, and next points to the next element. You guys following so far? Next in the loop, what happens? Next equal to 3 dot next. What is 3 dot next? Address of
4.
4. So whatever the value here, 3 dot next, which is 4, we store here address of 4. Now current dot next equal to previous. Look at that. Current dot next equal to previous. What is previous? Previous is 2. That means current is 3. So 3 dot next connected to this one, right? That means we are eliminating this link. We already eliminated 2 connected to 1 and 3 connected to 2. Is it clear?
Yes, sir.
Now what is the next one? Previous equal to current, current equal to next. Previous equal to current. That means previous equal to current. Previous, that means 3, and current equal to next, which is 4. Now look at the last iteration. Now last iteration is current 4 not equal to null. Now 4 not equal to null. Next equal to 4 dot next. What is next? 4 dot next. 4 dot next is, here it is null, right? There is nothing here.
Null.
So
Null.
next equal to null, right? And next what happens is 4 dot next equal to previous. This is previous, right? Now this becomes previous. This is previous. This is previous and this is current. So current dot next equal to previous. That means 4 connected to 3, right? Isn't it? 4 connected to 3. Next, previous equal to current. Previous equal to current. What is current? Previous equal to current is 4. That means 4. And current equal to next. Current equal to next. That means current becomes null. Now this is where the loop ends. Look at the loop here. Current equal to not equal to null. If current not equal to null, that is the only case it runs. Now current is null. That means it exit. Now you have to decide where to put the head. This is very, very important. Unless you change the head, head is always pointed to 1. You did not modify head here, right? So in any of these lines, we haven't modified the head value. Now we have to modify the head value. This is the time to modify the head value. Simply head equal to previous. What is previous? Previous is 4. That means head equal to 4. That means head equal to 4. 4 connected to 3. 3 connected to 2. 2 connected to 1. That's it. You're done with reversing the entire linked list. So very tricky. It's not easy, I know, but it's kind of by heart. You have to understand. It's not like blindly by heart. It's understand and then by heart. These are the these are kind of a secret code kind of thing. It's kind of a mantra. There is if you did any mistake here, your algorithm will screw up. You have to be very careful, and you have to understand every line, where to put next, where to put, how you updating. So it's kind of a Sanskrit mantra kind of thing. This will do the magic.
Sir, I have a doubt.
Yeah, go ahead.
Sir, when we are initializing the next variable,
Mm-hmm.
can we initialize it with the head dot next? And I have given, sir, in the chats the algorithm, which will be in the while loop.
Okay, let me look at your algorithm. The while. Okay. So what you did here is current dot next equal to previous, previous equal to current, current equal to next, next equal to. Oh, let me understand this whole thing. So you want to write in a different algorithm. So basically, let me copy this. Okay, and I copied from your thing. So what you're saying here is we will write something different, isn't it? Oh, I can't even edit here.
Yes, sir. We will initialize the next node with the head dot next value, but not the null value.
Okay, I'm copying here. Okay, so you want to do like this: current dot next equal to previous, previous equal to current, right? Current equal to next, next equal to next dot next. Let me look at this algorithm. So first one, what is the current? Current dot next equal to previous. This is exactly the same thing we did, right? Current dot next equal to previous. Okay. Next
Yes,
one
sir.
is
Yes, sir.
current
Previous equals to
previous
current.
equal
Sir,
to
these
current.
three lines are same. These three lines.
Oh, this is the only one you're changing. Next equal to next dot next.
Yes, sir. Yes, sir.
Next equal to next dot next. Here next is yeah next is next. No, we need to update the current, right? You already updated the current. Okay, you updated the current. But here, right? So you're asking about this question. We know we don't need this. We don't need this because you're updating the next year in the line number 65, right? You are storing
Sir,
the.
I am not using this line. I am not using this line.
Oh, you're not using this line.
I
Okay,
am,
you're
yeah.
next
Sir,
equal to.
at the 62nd line, the
Mm,
62 line,
mm,
sir,
here. Okay.
at the 62 line, I am just initializing the next variable with head dot next.
Okay, but if we had this null, what happens?
No, sir, I had this approach in my mind when I was doing this question
Okay. Yeah,
right now.
if you had this null, then that will be a problem. You should not say null dot next. Okay. But that's fine. But let me think. So
Yes.
if you're navigating only next equal to next dot next, so we need to write a table so then we can understand. So current dot next equal to previous. I think it will also work. It may also work, not a problem, because basically you are storing the value of the next value, right? So the address of the next value, it still works, I think. Yeah, it's basically writing in a normal loop kind of thing, rather than storing you are asking current dot next, you are simply storing the next dot next. Yeah. So have you tried executing that logic?
Yes, in this I'm using the next as a loop invariant.
Yeah, yeah, that's right. Anything will work. Yeah, either this will work or you can also use the next value. But our simply idea is the same thing. As I said before, we need to have a three things: current, previous, and next. And you need to update the addresses. It's kind of chaining. Okay. I hope others also understood.
Yes, sir.
Yeah. Jay, is it clear or is any problem?
No, sir, it's clear.
Okay. How about Sunil Kumar or Sam or Tarun? Others just dropped. I don't know. Chandana or somebody dropped. Is it clear, Tarun and Sam?
Yes, sir.
Okay.
Yes, Suresh. And
Cool. Cool.
last
That.
time also
Yeah.
same.
Yeah. This is also kind of another problem where reverse a linked list in pairs. So this is let's say if you want to reverse a linked list by pairs, you need to link a list. Let's say 1, 2, 3, 4, 5 becomes like 2, 1, 4, 3, 3, 4, 3, and 5. Basically, two. I want to reverse these two elements. I want to reverse these two elements. It is also tricky. I don't ask these questions and to be frank, I don't ask this question in the interview, but some people will ask. So how to do that? It's a similar tricky manipulation of the addresses. So I will send this link. You can go through that. But it is always important to write a table like this. If you write the table like this, and if you will be able to crack the code, otherwise you will not be able to understand. This is pretty sure. So it is very difficult to understand this code without having pen and paper. Okay. So that's how we have to understand this code. This is reverse pairs. Reverse pairs. It is also, yeah, reverse list pair uses another algorithm called reverse pair. So here is the reverse sub algorithm. So basically, yeah, you reverse the nodes. This is additional data structure, right? If you want to reverse the nodes in a in the linked list, you can use the additional data structure as well, as somebody said, right? So this is like reverse the nodes with the k value. So is here I'm saying like reverse the pairs, right? If you want to reverse the pairs, this is the algorithm, but not pairs. If I will give you k, this is actually the algorithm that I want to discuss today. So basically, let me show you. So this is the algorithm. So reverse the linked list in a group of given size k. So reverse the entire linked list. We just discussed about it. Reverse the pairs. How to reverse the two elements at a time, right? And here is reverse the group of k nodes. So there are two approaches. You can use extra space. You can no need to use extra space. So how to reverse the pairs? I can go through this, but it's kind of tricky again. So we already know how to reverse the pairs. Like if we have two nodes, right? First node and previous node. So how to reverse? Basically, first node connected to like previous node connected to first node. Now wait. Yeah, first node and previous node. So if the first node is null, you just return null. You can't even reverse it, right? So first node at next is null. Okay. Then what we do? We just include the first node. Okay, reverse the pairs. Otherwise, second node equal to first node dot next. Third node equal to second node dot next. Let me see what is happening here. First node, previous node, second node equal to first node dot next, third node equal to second node dot next. Yes, that is the third node. Next, second node dot next equal to first node, and first node dot next equal to third node, and previous node dot equal to previous node dot next equal to second node. Okay, this is kind of a tricky thing. So how to reverse a pair? Okay, this is first we need to understand that. So reversing a pair. Okay. So somebody just joined again. Okay. So reversing a pair is algorithm has first node and previous node. Okay. We have first node. Let's say this is first node and this is previous node. Just a variables. Okay. This is first node and previous node. Okay. We need to reverse these two nodes. Okay. How to do this? So that means this, as we discussed before, it's not reversing the entire linked list, right? So what we need to do, first one is reversing means this node connect to this node and this node should connect to this node, and we need to remove this connection. That is what the reversing, right? Now what happens here, let's say it is 1 2 3 4, 1 2 3 4. Now what happens here, 2 1 3 4, you reversed these two, isn't it? Right? If
Yes,
you
sir. Yes.
So now it started with two. Actually, technically it is like by looking at the whiteboard, you're thinking one is the first node, but it is not. So basically, 2 1 3 4. You reversed it, 1 and 2. How to do this? This kind of swapping is happening here in this algorithm. If we look at carefully, if first node is null, you don't need to do anything null. If first node dot next equal to null, simply return the first node. Let's say there is no next node here. If there is no 3, then simply return 2. Otherwise what we are doing is second node equal to first node dot next. That means, so let's have this kind of variables. As I said, this is always requires the table. So better to have the table. We have first node, second node, third node, previous. So let's have elements previous, first node, and second node, and third node tn. Okay. So we have these variables. It is always tough to understand. We will try. So second node equal to first node dot next. Okay. Let's assume that first node is 2. The value first node refers to 2 and previous refers to 1. Okay. Initially this is what we have. Right? So this is the connection we have. So first node is 2, previous is 1. Now what are we doing here? Second node equal to first node dot next. That means first node dot next is 3. Second node equal to 3, and third node equal to second node dot next. Third node equal to second node dot next, which is 4. Right? Next, what are we doing? Second node dot next equal to first node. Second node dot next. Second node dot next equal to first node. Okay. Oh, we are reversing 2 and 3 here. Oh, I see. I see. The question here is not reversing this first node and previous node. So we are saying reverse the pair starting from first node, and whatever the next node, and make sure this is the previous node of this first node. Okay. So what we are doing here is, so we are reversing 2 and 3 here. Okay. 3 dot next equal to first node, and first node dot next equal to third node. That means first node dot next equal to third node. Okay. We updated 3 connected to 2. That means we remove this link. Okay. 3 connected to 2, 2 connected to 4. Okay. Now what we need to do is, if previous not equal to null, previous dot next equal to second node. Previous not equal to null. Yes. Now previous connected to 2. Now what are we doing? Previous dot next equal to second node. What is second node? 3 is connected to 3. So now we are removing this link. So now what happens here is return the second node. Now we are returning the second node. Finally, we will return the node number 2. That means now what happens? 2 connected to 3, right? 3 connected to 4. Okay. Now previous dot next equal to, yeah, 1. Actually 1 connects, sorry, this is what happened. This is what happened. 1 connected to 3, 3 connected to 2, right? 2 connected to 4. Finally we reversed 2 and 3, isn't it? That's why we are again, now we are sending the second node. We are sending the second node. What is second node? 3. No, wait. Yes. We are sending the, finally we are sending the second node. Are we updating second node here? No, second node. Yeah, we are sending the second node, which is 3. We completed reversing the 2 and 3, and we are sending the 3. So at the beginning of the algorithm, we have 1, 2, 3, 4. At the end of the algorithm, we got 1, 3, 2, 4. Right? So these are the reversing of the 2 elements. Now we call that algorithm, this is the reverse pair. We call this algorithm in a bigger algorithm. Look at this. This is reversing every pair. So we took another variables like no n equal to head, previous, and head 2, and we have these conditions n not equal to null, n dot next not equal to null. Then we are reversing the 2 pairs, and then we are updating the head 2, and if head dot next dot n dot next not equal to null, we are updating the previous node and also next node. So finally we are looping through this. So please take the tables and variables. This is always important. As I said, take the variables and previous head to and everything and run through this algorithm. You will definitely able to solve this algorithm. This is reversing the pairs. Okay, these are complex algorithms. I technically, personally, I don't ask these questions in the interview because it's kind of by hearting. The people who by heart, then they can only write this, or at least if you know the concept, you can explain the algorithm, but you will not be able to write these tricky algorithms. It's a kind of tricky, right? It's manipulating addresses. But even if you write this algorithm 100% correct, what is the point? Like I don't get the logical question here, right? It's not a binary search, it's not a heap sort or any kind of, it's kind of a manipulation of addresses, which we don't do regularly, right? So technically, personally, I don't ask this question in interview, but it is one of the very popular question in interviews. Somehow people will ask in Microsoft or Amazon. It's pretty common question. They ask, "Hey, pair like reverse the pairs in a linked list." Reverse the pairs or reverse the entire or reverse, this is another link which is complicated. The next one maybe we'll discuss next week. So reverse the k elements. If I say k equal to 3, you need to reverse the 3 elements at a time. If you have a big chain of 100 elements, if k equal to 3, every 3 elements you need to reverse. But at the end of the day, after ending of the algorithm, you still need to have the 100 elements. You should not break any of the linkages. If you break the linkages, your algorithm is screwed up, right? So this is algorithm. Maybe we'll discuss next week. Otherwise, we are good to go, I think. Any questions so far? Is it helpful, or how is the session for the newcomers? I think Jay and Sam.
Yes, sir.
Very good, very good. I'm going to, for the quick reference, I'm going to, put the algorithm links here itself. You can save immediately before we log off the meeting. And if you sign up um, into the, what is that, the Discord, I will send the recording as well. Okay. Let me see. So let me find this here. My monitor is always like flickering all the time. So let me remove it. Okay. Uh, questions, anyone?
Sir, Discord link.
Yeah, I will. I already sent the Discord link. I can send again. So, do you have Discord already?
Yes, sir.
Okay, cool. So ping me there, and please join every week so that you will get more and more, sessions, practices. Yeah. Cool. Then have a nice week, and we'll discuss next week another linked list problem. Okay. Awesome.
Yes, sir.
Yes, sir.
Awesome. Let me stop sharing. Stop recording before I sign up. I think stop recording is here.